Newton's first law. Statement: every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by a net external force. Here it is a body with mass m at rest and another body in uniform motion. From these illustrations, we can say that every body continues in its state of rest or of uniform motion in a straight line unless it is acted upon by a net external force. There is no net external force in both the cases. This law enables us to define inertia and force. From this law, it can be concluded that if the net external force on an object is zero, the acceleration of the object is zero. Inertia. If the net external force is zero, a body at rest continues to be at rest, and a body in uniform motion continues to move with uniform velocity. This property is called inertia. It is the resistance to change the state of rest and the state of uniform motion. Mass is a measure of inertia. For example, when we are in bus that starts suddenly, our feet in touch with the floor would be accelerated by the frictional force to move along with the bus if the acceleration of the bus is moderate. While our feet go with the bus, the rest of the body remains where it is due to inertia of rest, that is, we fall backwards. Similarly, when the bus stops suddenly, our feet stop due to the friction, but the rest of the body continues to move forward due to inertia of motion. If the net external force is zero, a body at rest continues to be at rest, and a body in uniform motion continues to move with uniform velocity. This property is called inertia. Force. It is the physical quantity that changes or tries to change the state of rest or uniform motion along a straight line. The forces, gravitational force and frictional force, are in equilibrium at the rest. Various forces in nature. 1. Gravitational force. 2. Electromagnetic force. 3. Nuclear force. 4. Weak interaction force. Gravitational force, which is responsible for the attraction between various bodies in the universe. The magnitude of the force is directly proportional to the masses of the bodies and inversely proportional to the square of the distance of separation. F is directly proportional to m1, m2, and F is directly proportional to 1 by r square. Therefore, F is equal to G into m1 m2 by r2. B. Electromagnetic force, which is propagated through electric and magnetic fields. Like gravitational force, it is also felt over long distance. An example of electromagnetic force is the interaction between the molecules of a substance. C. Nuclear or strong force, which is responsible for binding protons and neutrons in an atomic nucleus. It is felt over short distance of the order of 10 to the power of minus 13 centimeters. D. Weak force, which is responsible for the phenomenon of beta decay in radioactivity and decay of many elementary particles. It also acts over very short distances.